Hi, in this video we want to look at how to add parallel vector. When a vector moves in the same direction or the vector moves in exact opposite direction, they are known as parallel vector. Now let's say we have a vector A, let's use a black pen now, a vector A, and vector A has the value 6 and then the value 8 to the east. And then we have vector B. Vector B has the value 6 and then also have the value 2 to the east. Now you are asked, what's the magnitude of this vector? Because they are moving towards the same direction, you know, we have the coordinate system, we have the east, we have the north, we have the west, we have the south. Now, because they are moving in the same direction, the resultant vector is vector A plus the vector B. And that is going to give me actually 6 plus 6. That's what we'll be having. We'll be having 10, 10, 1, 12. Okay? Now, we're going to be having 8 and 2, which is 10. Now, the direction of this vector is east. The direction of the vector is east because they are moving in the same direction. Now, let's say the vector A has the value 6, and then vector B has the value 5. And let's say to the east, all right? And let's say vector B has the value 6 and the value 4, and it's moving to the west. Now, what's the magnitude of this vector? The resultant magnitude of vector is vector A minus vector B. Why are we using the minus? Because they're traveling in the exact opposite direction. So what we're going to be having is this. 6 minus 6 is 0, 0, and then 5 minus 4 is 1. Now, this vector will remain at the positive axis. That is, it's going to remain at the east position. If you recall, remember that this is your positive x-axis, negative y-axis, negative x-axis, okay, positive y-axis, negative x-axis, and negative y-axis. Sorry for that, positive x-axis. Now, you recall that this vector is going to be somewhere around here towards the x-axis because we have 0, 1. Let's say we have another vector. Let's say we have another vector. Vector A is equals to, let's say, 4, and then let's say 5 to the east. And then vector B over there now is equals to 4, and then let's say we have 3 to the west. Now, to the west. Now, what's the magnitude of this vector? Let's change this to 6 because we need a negative value. What's the magnitude of this vector? The magnitude of the resultant vector is equals to vector A minus vector B. Well, that's going to give me 4 minus 4, that is 0, and then 5 minus 6, that's a minus 1. Now, the minus value there is the direction pointing you that is moving towards the west. All right, so this is the value for that kind of answer. So this will be towards the east, this will be east, and then this will be west. All right, having said that, let's move to another question. Let's say we have a vector of 40 Newton and it's moving or is directed eastward. And then vector A now, and a vector B, let's say another 40 Newton, and is directed east. Now, the resultant vector is simply 40 plus 40 which is going to give me 80 Newton directed to the east. All right. Now, but if the vectors are moving in opposite direction, let's leave the 40 Newton to the east, and then another vector, let's say 30 Newton to the west, 30 Newton to the west. All right, and this is vector B. Now, the resultant vector is simply 40 minus the 30. All right, so we're going to be having the resultant vector should be 10 Newton, and 10 Newton directed to the east, eastward. 10 Newton eastwards, because if you, let's say you're moving like this, you move to this point. This is, you're going 40 Newton, and then you return back to the west, okay, 30 Newton. Now, your displacement is 10 Newton, but you are still at the east, okay? So you're still at the east, so the displacement or the resultant vector is 10 Newton east. Let's make a picture, or let's make a more considerable question. Let me clean up this, because we're going to need that. We're going to need that for this question. A man walked 10 kilometers to the north, okay, and walked, that's an illustration, 4 kilometers to the east, and also walked, let's use the comma there. A man walked 10 kilometers to the north, comma, just use the comma, let's bring it on together, or let's just put it on, we have put it already, or normally it's supposed to be a man walked 10 kilometers to the north, comma, walked 4 kilometers to the east, comma, walked. Okay, all this and is not supposed to be there. Let's make it a more suitable English structure. All right, because in English language that would be very wrong. So the man walked 10 kilometers to the north, and then he walked 4 kilometers to the east, then walked 6 kilometers to the south, and finally walked 4 kilometers to the west. Find or calculate the final displacement. Now, let's take the question. A man walked 10 kilometers to the north, walked 4 kilometers to the east, walked 6 kilometers to the south, and finally walked 4 kilometers to the west. Calculate the final displacement. We can use a picture to solve this problem. All right, now look at the picture. This is the coordinate system. The question says that he walked 10 kilometers to the north. So this is 10 kilometers. And then he walked 4 kilometers to the east. This is 4 kilometers. And then he walked 6 kilometers to the south. So 6 kilometers will be less than 10 kilometers. So this is 6 kilometers. And then he walked 4 kilometers to the west. So this is 4 kilometers. Now I want you to look at me now. Look up here. Now if I walk from here to this point, okay? And then I walk back to where I started walking from. Now, is there any displacement here? No, there is no displacement. The displacement here is 0. Let me show you what we mean by that. When we have the coordinate system, let's say we have the coordinate system, and then this is 0 minus 2 minus 4 and then this is minus 6, and then this is 2, minus 2, and then minus 4. All right, now let's say I walked from here to this point, and I walked exactly back to this point. What is my final displacement, which is change in x, or change in x? Change in x is equals to my x final minus my x initial. Now, what's my x final? X final, look at the board there. X final is minus 2. So I have minus 2 minus, what's my x initial? X initial is minus 4. Now, what do I have? Minus will cancel out minus. Minus times minus is positive. I'm going to have minus 2 plus 4. Now, finally, what I'm going to be having now, minus 2 plus 4, I'm going to be having 2 as my final displacement. But meanwhile, if I was to get to this point, this is the final displacement for this illustration. What if I have this illustration? And then I didn't stop over here, but I moved till I got to this side, till 4. All right, till minus 4. I started out from minus 4. I came back to minus 4. Look at my final displacement. It will be in a final velocity or final distance travel displacement, which is minus 4, okay, minus the initial one, which is minus 4. Minus will cancel minus, so I have minus 4 plus 4, which is equals to 0, meaning there is no displacement here. Now, this guy travels 10 kilometers to the north, 4 kilometers to the east, 6 kilometers to the south, 4 kilometers to the west, meaning this guy is going to go out. So what we have now is now 10 kilometers to the north, and then we have 6 kilometers to the south. The final displacement is simply 10 minus 6, which is going to evidently give me 4 kilometers. 4 kilometers northwards. First 4 kilometers to the north. 4 kilometers northwards. Or 4 kilometers to the north. So that's how to solve this kind of problem. This is all we've got for you in addition of parallel vector. Thank you very much for watching. Thank you for your time. And if you have a question, drop it on the comment section. And if this video has helped you at all, give it a thumbs up and don't forget to share. And you're always welcome to follow for more. Thanks for watching.